everyone. My name is Jana. Today we have another special guest. It is Dr. Matthew Holden. He is an assistant professor in the School of Computer Science at Carleton University. He completed his Ph.D. in computing at Queen's University in 2018 and his postdoctoral training at Johns Hopkins University in 2019. His primary research interest is in surgical data science, where he investigates machine learning methods for time series data collected in operating environment. This enables real-time decision support and quality assurance during surgery with the goal of improving patient outcomes. So hi, how are you today?
Hi, Dana. Thanks for inviting me to be here. I'm well. How are you doing?
I'm great. So thank you so much for coming. We're very excited to hear about your research and how you got into AI. Okay, so we'll get into the questions now. So one of the first questions we're really interested in hearing is how you became interested in technology and artificial intelligence.
Well, that's a good question. So it wasn't necessarily an intentional thing. So what really started my interest actually was improving patient outcomes in healthcare. So I had started working on this really interesting project where we were trying to improve training in ultrasound guided interventions. And it turns out that the best way to do this was using some methods for artificial intelligence. So we started out with trying some basic unsupervised clustering and using state transition models. And then what I realized is, well, actually what's most interesting about that is the techniques and methods in artificial intelligence. So that's when I started exploring more theoretical aspects of artificial intelligence. But my work still is related primarily to healthcare and interventional healthcare and how we can improve patient outcomes there.
Okay, cool. So you mentioned that you do research in like AI and healthcare. So what is your day-to-day experience and what do you do day to day?
Well, so like most academics, your time is split between a variety of activities. There's teaching and research primarily, but from a research perspective, a lot of my time is spent reading papers that other people have written about related works to help myself understand what's going on in the domain. And then the other thing that I primarily spend my time doing is meeting with people. And I know that might sound boring, but it's actually quite interesting. So much of the work that I do is very translational. And so it requires collaboration with clinical colleagues. We have to understand what the clinical problem is, the constraints associated with it, and then together we need to work on a solution. And those solutions should somehow incorporate that domain knowledge that we have from our clinical colleagues. So those are the sort of two primary ways that I spend my research time. Of course, the other thing, in addition to the fun stuff, if you will, where we actually implement new methods to improve surgical outcomes, new deep neural networks, which seems to be the current trend. The other thing is we spend a lot of time doing data curation and data wrangling. So we collect this data in a variety of environments, either the operating environment or a simulation environment. And it's very messy. And so one of the practicalities of working in this space is that we actually have to spend a lot of time going through the data, cleaning it up, making sure it's in a form that is amenable for our models.
So within your research, I was just wondering what technologies do you get to use and how are they useful towards your research?
Yeah, so we use a variety of hardware technologies as well as software technologies. So in the context of improving patient outcomes in interventional healthcare, we try to deploy sensors in the operating room environment. So we use things like pre-existing medical imaging devices, things like your standard MRI or CT machines that you might find in a hospital. We make a lot of use of ultrasound imaging. And so those are things that might already exist in a clinical setting. But in addition, we deploy other sensors. So we deploy things like position and orientation tracking systems. This allows us to track tools or maybe our operators' body parts or our patient's body parts as the surgery is ongoing. We also deploy things like sensors to monitor the patient status, and sensors to monitor the operator status. So things like sensors to track their eye gaze, to track maybe their muscle activity and that kind of thing. So those are some of the hardware technologies that we work with. The software technologies that we work with, one of the primary applications that we use is a program called 3D Slicer, which is a medical image computing and computer-assisted surgery platform. This allows us to capture imaging data, visualize it, and compute various quantities. And the other software we use is, of course, there's an ongoing trend to use deep neural networks as one way to do supervised or unsupervised learning. So we take advantage of some of those deep learning libraries. So like your TensorFlows, like your PyTorches, etc.
Okay, cool. That's a lot of things that you would use then.
Yeah, well, that's the thing about this sort of interdisciplinary work. We have to, deploy technologies that are amenable to the operating room, but we also have to take advantage of our modern numerical computing and deep learning technology.
Okay, so I have a question. So you're now using artificial intelligence, and so how in what ways do you think artificial intelligence have added value in healthcare?
Yeah, that's a really interesting question. Um, so I think there are sort of there are many ways that we could have added value in care, but I see sort of four primary ways that our work in interventional healthcare using artificial intelligence has added value. The first is in clinical decision support. So if we can, using artificial intelligence, somehow understand what is going on in the operating room at any given time, then we can try to assist clinicians to and tell them or suggest to them what might be the next course of action in the surgery that's going to best optimize the patient's outcome. The second way we can do this is is increasing the surgical efficiency. So if we can identify, for example, how much time is left in an operation, then we could know when to start preparing the operating room or preparing the next patient to use the operating room. The third part is we could use this to identify where technology can have added value in a surgery. So maybe we try to introduce a new instrument or tool. Where is that going to have added value and how much? If we can understand how the introduction of the technology affects patient outcomes, affects the progress of a surgery, then we can really understand whether that technology is a good thing or bad thing to incorporate. And then the final thing is we can use artificial intelligence to improve training. So if we can, for example, understand or classify or assess trainees, understand their skill level and classify them as to whether or not they're proficient at an intervention, then we can use this to inform training curricula.
So basically it can help with like efficiency and quality then.
Exactly, exactly. And of course, the ultimate goal being to improve patient outcomes.
Hmm. Okay, that makes sense. That's actually really cool. I didn't even know that AI would have so much um, impact on healthcare as well. Um, so, within your research, have you found any challenges of deploying artificial intelligence into healthcare situations?
Yeah, that's a very interesting question. So I think one of the main challenges is that healthcare is a very high stakes environment. Um, the healthcare decisions that we make can have significant impact on a patient's quality of life or a patient's mortality. So when we deploy artificial intelligence-based solutions, we need to make sure that they're not negatively impacting patient outcomes. And so there are a few ways that we can try to ensure this. But the real challenge here is that not only are these high stakes decisions, but it's a very complex domain to model. And so patients have a lot of heterogeneity, disease has a lot of heterogeneity. And so we need a very large database and very clever methods to tackle this in an automated method. So what we try to do is we try to build artificial intelligence that collaborates with clinicians. So that is, we try to somehow use artificial intelligence to improve things, make information more accessible to clinicians, provide them with support, but ultimately we try to leave these high stakes decisions in the hands of clinicians because they have years of training, years of experience. And so one of the ways that we do this is we try to incorporate our clinicians' domain knowledge into our artificial intelligence. So if we can somehow use that knowledge from our clinicians, incorporate it into our machine learning, into our algorithms that compute somehow the best decision or somehow a quantity of interest or information of interest to our clinician, then that can better help them to make their decision, and they can better understand why our methods are suggesting the information that they do.
Okay. So within your research, what types of data can be collected and analyzed intraoperatively?
Yeah, that's really interesting. So at the moment, we sort of look at four main types of intraoperative data. We look at medical images, so things like MRI, CT, which are more static images. We can also look at things like ultrasound or laparoscopic video, and those are more dynamic type images, or one might even call them video data. So that's the first type of data we look at. The second thing we look at is surgical navigation data. So in many modern surgeries, they use some sort of computer assistance. So somehow we track the instruments and the patient's anatomy. And so we can use that data to understand what's going on in a surgery as well. The third type of data is the patient status. So things like their vital signs, their muscle activity, their response to various interventions. So maybe how much they're bleeding, that kind of thing. And then the fourth thing we track is the status of the operator, the surgeon or the surgical team. So we can do that with eye gaze trackers, with muscle activity monitors, that kind of thing. And so that data we collect intraoperatively, but we also combine that with data that we get preoperatively. So the preoperative data we get are things like the medical records or medical history of our particular patients. We can build preoperative atlases of what our disease or our pathology look like. And we also have domain knowledge about what the intervention entails and how it progresses. So if we combine these sources of intraoperative data with that preoperative data that we can generate beforehand, that's when we can really best analyze our intraoperative data and facilitate the intervention.
Okay, so we'll move on to a more general question now. So many people have been speculating the future of AI and how it could change the world. In your perspective, what is the future of AI in healthcare or just like generally?
That's a really good question. A tough question. So maybe I don't think I could predict the far future of AI, but maybe I can speculate sort of on the nearer future. And from my perspective, the sort of near future involves collaboration between humans and AI. So especially in healthcare where we have to make high stakes decisions, but I foresee this in many applications. AI is really good at doing specific tasks, so answering a very specific classification or regression problem. But humans have a sort of general intelligence that we haven't yet been able to capture with AI, and it seems, at least from my perspective, to be far off, that we're going to achieve a semblance of the general. So I think the sort of future is having our artificial intelligence collaborate with humans in order to help humans solve problems more efficiently, more effectively, but not replacing humans. Simply, as I say, make things more efficient for our humans so that they can perform tasks better.
Okay, so as you mentioned, you were not originally going to go into technology or artificial intelligence, but it turned out that way. So we were just wondering if you had any thing you would do differently, so failures or regrets, anything you would like to change or whatnot. And like with that in mind, do you have any advice to share for beginners trying to break into AI or for academics, anything in general?
Yeah, of course. I've made a lot of mistakes over the course of my career. Would I do things differently? Uh, I, I I think the one thing that I would do differently is I would start to explore the more theoretical aspects of artificial intelligence sooner. So as we've all seen over the past decade or so, there's been an explosion in the interest associated with neural networks and deep learning. So the thing that I would have done differently is, well, and I think many people in hindsight would have done this differently, is become involved in such work sooner. And so I think going forward, sort of embracing these new technologies more readily is going to be beneficial to all of us. Do I have any advice for people getting started in artificial intelligence? I think my big advice is to make sure you have the sort of foundational skills to do this. So make sure you have the background in statistics, make sure you have the background in mathematics, and that will really help you moving forward in artificial intelligence. But I think sort of the big thing is find something you're passionate about, find an application of artificial intelligence you're passionate about. So in my case, this was artificial intelligence to improve interventional healthcare. And so this is really what drove my research and my interest in artificial intelligence. So I think finding an application area that you're passionate about really makes artificial intelligence an interesting and practical thing to explore.
Well, thank you for the advice. We just have one last question. So you mentioned that in your research of interventional healthcare, a lot of collaboration takes place, and often enough, you do use data from MRIs and whatnot. So how has COVID-19 affected you and your work?
Yeah, that's a really good question. So of course, COVID-19 has caused a paradigmatic shift in the way that we all work. You know, I know it's affected students, faculty, staff at universities significantly, and of course, it's affected our whole society significantly. And so there has been a lot of extra effort put in by everyone in order to try to maintain the teaching and research that is so important to our university. So first I want to thank everyone who has been working so hard during this pandemic. I think the primary ways that it's affected this sort of research in healthcare is that a lot of the resources at our hospitals have been dedicated towards dealing with COVID-19, treating patients, providing education to society and to our population in general. And so a lot of the research that has gone on in the hospital has shifted in priority. So rather than research on things like training and instruction, we have shifted a lot of our research towards improving treatment for COVID-19, learning about the spread and the and modeling the development of COVID-19. So from our perspective, a lot of our research has sort of gone on pause almost, because we simply don't wish to use or in our collaboration with our clinicians don't have the capacity to engage in this type of research at the moment, but rather are focusing on the ongoing pandemic. So this allows us to, instead of collect new data sets, to retrospectively analyze a lot of the pre-existing data that we have and discover new insights that way. Our sort of long-term goal is that if we can use some of our technology to help in the treatment of COVID-19, that would be really fantastic. Although from our perspective, this is a little bit challenging because we don't even know what the best strategies for treating COVID-19 are at the moment. So our research would really be more related to improving treatments or improving their efficiency of treatments once they exist. But this sort of vaccine development and other treatment development is the primary focus of our clinical colleagues at the moment. And so our research will hopefully take over and facilitate treatment eventually, but at this point in time, we're not able to contribute there directly.
Right. That would be great if a vaccine could come out. I think everyone would be so excited.
Yeah, obviously that would be a huge thing for our society. And so I am optimistic that this will be developed soon, but of course the timeline at this point is uncertain.
Right. So we'll end the talk here today. Thank you so much for coming. It was very insightful, and I'm sure all our listeners will have learned a lot and discovered something new about AI.
Thanks very much for the invitation. Really appreciate the time that you've taken to chat. And I just want to say that I think the Carleton AI Society is a really great thing that you and your group have been spearheading, and I appreciate your efforts towards that.
I just want to ask, would you like to add anything before we just end the podcast?
I don't have anything in particular I want to add other than to thank you and thank the listeners for making this an interesting discussion.
Thank you so much for coming. We're so excited that you could be part of our second episode. So yeah, my team and I all thank you for coming and sharing so much of your knowledge with us.